Welcome back to this video lecture series on data structure and algorithms. Today we will be discussing about a very important algorithm that is known as knapsack problem. So let's start. So the problem statement that is the main thing that we have to understand. It says given weights and values of n items, put these items in a knapsack of capacity W to get the maximum total value in the knapsack. In other words, given two integer arrays, one for storing the values of those elements and another WT, or that stands for weight, that stores the weights of the elements. These represent again values and weights associated with n items respectively. Also an integer will be given, that is W, which represents the knapsack capacity, that is the maximum weight that the knapsack can hold. Now we need to find out the maximum value subset of val such that sum of the weights of these subset is smaller than or equal to W. Some things to remember while we solve this problem is that we cannot break an item, either pick the complete item or don't pick it. So what we are going to do is we are going to encounter with the 0-1 knapsack problem. There is another kind of knapsack problem that is known as fractional knapsack. So whatever, let's go forward with this 0-1 knapsack problem and let's have a look at one of the examples. So this is a very simple and general 0-1 knapsack problem. Suppose these are the two arrays that are given value and weight, and these are the values 60, 100, 120 for value and 10, 20, 30 for weight. Also this variable called W, or the knapsack capacity, is given, which is having a value of 50. So our aim is to find out the maximum value that will be a subset of the value array in such a way that the total weight of those elements will not exceed the value of W. So if we take combinations, if we take let's say the weight is 10, the value is 60. These are the set of given informations. Now if we take the first two items, we can see the weight combined is 30, value is 160. So there can be a scope that the weight remains within 50 and we can get a higher value. So we move forward to test. So let's say we take the first and the last, so 30 plus 10, 40 within 50, and the value stands as 180. We go again forward and we pick up the last two elements whose combined weight stands out as 50, and the value also stands out to be the maximum one. So as we pick these two elements 20 and 30, and the sum of them is less than or equals to this capacity and also produces the highest value if you compare all these three values. So this obviously can be the answer, and this is very obvious because if we choose to pick all the three, we can see that the sum of the weights exceed this knapsack capacity. So this is the very plain logic. Now let's jump on to the programming part and see how we can implement this. So I've already opened my IDE and typed down these lines of codes. So this is the array we're going to take for value. This is the array we're going to take for the weight. And this is the knapsack capacity. So here, first we will be needing the size of the array val. So for that, we'll use some size of operators. So this will be size of val divided by size of val 0. Now we need to print out the maximum result. So I'll say just that the result percentage d, new line, and here the value of this percentage d will be the value returned by the knapsack problem solution. So we'll be using a function for this. So I'll be calling the function here only. The arguments will be the capacity, the val array, the weight array, and the size of the array val. So this is the thing. So we just need to define this knapsack function. So as we can see, the return type will be integer. Now the argument types int, then this is a integer type array. This one is also, and again this is another integer. So here first we define the base case, that if n is equals to 0, or we find out that the knapsack capacity is 0, then we simply return a value of 0. Now we have to check if the nth element is having a weight greater than the knapsack capacity. So if w of n minus 1 is greater than the knapsack capacity, what we do is we exclude that nth element. So we do a recursion call of the knapsack function, and the only change will be the value of the size of the array will be n minus 1, because we are excluding the last element. And if this is not the case, then we will have a else part, in which a very simple thing is to be done. We have to return maximum of two things. These two things will be, one is the you know uh, chance or a possibility where the nth element will be included, another one where that will not be included. So if we go for the including the nth one, then val of n minus 1 plus, again, a knapsack call on the rest of the n minus 1 elements. So w, then val, then this array and n minus 1, and another one excluding the nth element. So I can simply copy this. So just copy and paste it here. Let me just do a bit of indentation here. What I can do simply is, right, so we just need to define this max function here, which will definitely return an integer. So the arguments will be two integer values, let's say a and b, and will return if a is greater than b, then a, or else b. This is a very simple definition of this program. Okay, one thing before running that I have missed here is, uh, in here when we are returning maximum of these two possibilities, when we are taking this possibility of including the nth element, we must see that for this knapsack function here, we have to exclude also the weight of the nth item. So weight of n minus 1, this will also need to be included. Now let's run the program again. As we can see, the output is here and it says 220. So our logic was implemented properly and executed rightly. Thank you for watching this video and staying with us. See you next time.